All right, even though I said you're not likely to see a law of sines ambiguous case, I thought we would do one as an example. So example 4 for the law of sines is the ambiguous case. So given that little a equals 25, little b equals 30, and big A equals 52 degrees, we're going to solve both possible triangles. So this is the generic setup of what this looks like, right? So I have my angle A that's 52 degrees, and I drew an approximate 52 degrees. This is not a protractor type situation. And I have B, which is 30, and then my A, because A is longer than H, which is B sine A, right? So B sine big A, 30 sine of 52 degrees. Because A is longer than that, A could either fall before H, making a triangle where this angle B is acute. That's the option 1. Or A could fall on the other side of H, which would make a triangle where angle B was obtuse. So those are the two different triangles that I could have. Again, it's a trick question when you see these kinds of ambiguous cases, but if I ask you ahead of time solve both triangles, I've already spoiled for you that there's a trick. So let's start with triangle 1. So I'm going to list what I know. I know big A is 52 degrees. I don't know big B. I don't know big C. I do know little a is 25. I know little b is 30, and I don't know little c, right? So I'm going to go ahead and do the law of sines. Now, we are going to do this triangle 2 where b is obtuse in a sec, but for right now, I'm going to erase it to give myself some space, and we're just going to focus on triangle 1, and we can go back and draw triangle 2 after. So I'm going to go ahead and do the law of sines, and you might not even choose to draw triangle 2 after. We'll talk about that in a sec, about how once you find b, you can find both versions of b and answer the question. So I'm going to go ahead and do law of sines for B, big B, using the pair that I have for A. So the law of sines says that the sine of big B, which I don't know, over 30 should equal the sine of 52 degrees over a 25. Multiply the 30 over, and I get that sine of B should be a 30 times the sine of a 52 degrees, all over a 25. So my B is going to be the inverse sine of this whole mess. So here's the part where you're able to solve this without drawing the second triangle if you so choose, right? So when you picture an arc sine, right, remember that sine of an angle is the y on a unit circle, right? So whatever value you get in quadrant 1, which is going to be your acute angle, let's say you get an angle here, there is a matching value in quadrant, oh, sorry, let me inch this over for you. There's a matching value in quadrant 2, right? So here's quadrant 1 and here's quadrant 2. Right? There's a matching value across the y-axis in quadrant 2 that has the same sine value, right? So that's really the other version of B. We can find both versions of B right here, right now, without ever drawing the second diagram. The one that the calculator is going to give me is the one in quadrant 1. So I'm going to go ahead and do the inverse sine, so second sine, and I made sure I was in degree mode because I was doing calc the other day, of 30 times the sine of 52, I'm in degree mode, divided by a 25. So that's what I'm putting in my calculator, right there, and I hit enter, and I get an angle that is acute, which is what I expected. So I get B, and I'm going to go ahead and call this B sub 1 because this is my B in my first triangle, to be 71.016 degrees. Excuse me. All right, so I have this B, and I'm going to store that as B because I realize that reasonably I'm going to have to use it again. So, again, I'm going to store it as B. Pardon me, just need a little water. All right, so I'm going to hit stow in my calculator, which is the button right above on, and I'm going to hit stow, alpha, B, and now I have that stored in my calculator. So I can use that B to find what angle C is, right? Because I know that the sum of the angles in a triangle is 180 degrees. So I'm going to do 180 minus, and then in parentheses, 52 plus the thing I just stored as B. So 180 minus, in parentheses, 52 plus alpha B. And that's going to give me my value for C in this triangle. So my C should be a 56.983 degrees, right? And I'm going to store that as C, right? I'm going to store that as C because, again, I know I'm going to have to use it again. So I'm going to store it, right, and hit alpha C and hit enter. So now I'm going to use the law of sines again to find little c. So I'm going to do this same basic setup. I'm going to use A again, right? So I'm going to use the A pair because why use the harder pair that involves B when I can just use the one that involves the 52? So little c over the sine of the thing I stored as C, right, equals little a, which is 25, over the sine of 52 degrees. So I'm going to get that my little c is a 25 times the sine of whatever I stored as c divided by the sine of 52 degrees, which I'm going to type in my calculator, and that'll give me little c. So 25 sine of alpha c divided by sine of 52. And there's my c. So I get that my c is a 26.602, right? We always go to 3 places. So that's triangle number 1, right? Totally good, totally fine, all good. So now let's talk about, so those are my coordinates for, or my values for triangle 1. Let's go ahead and erase them, all right? And we're going to go ahead and find my stuff for triangle 2. But this b is still relevant, so I'm going to keep that because I still need it, right? And I'll just rewrite all this because it's a hot mess. All right, so here's what I know, right? So now I'm not trying to find this triangle anymore, right? Now I'm trying to find the triangle where a cuts back this way, creating a b that is obtuse, right? So there's my little c and there's my 25. Okay, so now my b is obtuse. Well, here's the thing about this, right? And I can go ahead and list them up here. I think I'll have room where you can see it. So my a is 52 degrees. I don't know big B yet, but we're going to find it in a sec. I don't know big C yet, but we'll find it in a sec. I know little a is 25. I know little b is 30, and I don't know little c yet because it's different than the one I just found. Okay, so now let's go back for a sec to the b that we found in the first part. So I've established, and I talked to you about this a little bit when we found it, that if this is my b that is 71 point stuff, and this is not drawn at all accurately, my angle is somewhere near 40 degrees, not 71, but it's fine. So if this value, right, if this was 71, then I could find this other angle by basically taking 180 and subtracting that value. So my b sub 2 is going to be 180, which is the negative negative x-axis, right? 180 minus what the thing I stored as b already, right? So if I take 180 minus alpha b, because I stored it, I get that my new b should be 108.983. So the thing I'm going to call b sub 2 is approximately a 108.983, right? Now I'm never going to need the old b again, right? The first b, 983 degrees, right? I'm never going to need this b again because I only needed it to find the new b, so I'm going to go ahead and hit stow and call it b. And I'm going to make a note to myself, stow b, and that this guy's no longer b, right? So now I'm going to go through the exact same set of steps that I did with the first triangle to find the c values. I'm just going to do them with this new b. So we established the last time that these 3 angles must sum to 180. So the way I found big C last time was by doing a 180 minus, in parentheses, 52 plus b. And I can do the exact same thing because I've already stored this as my new b. So I'm going to do 180 minus, in parentheses, 52, plus alpha b. And hit enter. And I get that my C is now a 19.016 or 7, depending if you round or truncate degrees. Cool. Once I find C, now I can go ahead and store this guy as C because I know I'm going to have to use him, right? So I'm going to store that as C, stow, and then alpha C. Again, I don't care that I'm overwriting the old C because I don't need the old C anymore. Once I find that, I'm going to use my law of sines the same way we did last time to find this little c, right? Little c over the sine of big C equals 25 over sine of the 52 degrees. I multiply this sine of c over, and what I'm going to type in my calculator is 25 sine of the thing I stored as c divided by sine of 52 degrees. So 25 sine of alpha c divided by sine of 52, and I hit enter, and I get what my c value is, which is a 10.337. Now, one thing to point out here, a couple little things actually. All of these should be squiggles because they're all approximate, not equal, right? These guys are actually equal. The other thing to point out here is that you can do a little bit of checking on your work, right? So when you go to look at this, your biggest angle should be opposite your biggest side. So the 100.8 degrees is the biggest angle, it's opposite the 30. The smallest angle, the 19, is opposite a 10, that's the smallest side. The middle angle, the 52, is opposite the middle of the side lengths, which is a 25. I already erased the stuff from part A, but you'd find that the same is true, or not part A, from triangle 1, because this is now triangle 2, right? This is my B is obtuse, sorry. This is my B is obtuse triangle. I forgot to erase the header at the top. So this is triangle 2, which is when B was obtuse. So again, in triangle 1, if you compared all the answers that you got, you would have found that the same thing is true. The biggest side is always opposite the biggest angle, and so on, which is a good way for us to run a mental check and also avoid accidentally being in radian mode, which happens.